All right, so next is the next step in the aldol reaction. So this is the aldol condensation. Sometimes this occurs spontaneously, other times you have to heat it. So for example, you start off with an aldol that you got probably from some kind of aldol addition. And then whether you're using acid or base and some heat, you're going to get a condensation reaction. So in this condensation reaction, we're going to kick out some water and we're going to form this type of product. Right. So kick off water because it's a condensation reaction. Again, this right here, whoops, was our aldol. This was the alpha position. This was the beta position. Here we have the alpha position and the beta position. So this is known as an alpha beta unsaturated aldehyde. Sometimes this is also called an enone, and so the ene means from like alkene and the one from like a ketone. Here it's an aldehyde, but you know, kind of same thing essentially, right? Carbonyl, they just went with the one ending. Otherwise, it could be known as an enal. Enal is the way you would say it with an aldehyde. But oftentimes I hear them being called enones, even though they're technically not ketones. Anyways, let's go take a look at the mechanism of this. So we have our aldol. We have this hydrogen right here. We have some base. And it's just going to do an elimination reaction. Note that in this case, the negative charge here is indeed an intermediate because it's resonance stabilized with that carbonyl. And then note here that we have formed water. And then this negative charge just kicks up to form a pi bond and then kicks out the hydroxide. We're allowed to kick hydroxide out because we're under basic conditions. This can also be done under acidic conditions, but it's more often done under basic conditions. And then if you think about what's left over is your alpha beta unsaturated carbonyl. In general, the trans product is preferred. Right, and that's just based on sterics. So get the big things away from one another. So if you have a more substitute alkene, generally the E product is preferred. Sometimes the Z product is preferred. It just the big things need to go far away from one another. And of course, our side products here are hydroxide and water. And it's important that water is a product here because all of these reactions are actually in equilibrium. And we can drive the equilibrium towards the right by getting rid of the water, right, through some distillation. And so this aldol, right, this starting material, often goes straight to the enone/enal. And so your addition product, you oftentimes can't isolate it. Sometimes you can, sometimes you can't. Oftentimes the reason that you can't is if this is conjugated with something else. So if there was like a benzene ring attached right here, you would not be able to identify, you'd not be able to isolate this because then this reaction would be so much more favored because of the resonance. If you can't, if it doesn't go to the enone right away, as long as you apply heat, you can get it to the enone. Here, ketones will work well for this reaction. So for example, if you had that cyclohexanone, we said before, if you add sodium hydroxide, you're not going to get much of the product. But if you add sodium hydroxide and a good amount of heat, so in this case, maybe like 100 degrees Celsius, you will indeed get the aldol condensation product, which is going to look something like this, right? And the reason that we can do this is because water is a side product, and then we can distill this away. And that's all based on the Chatelier's principle, right? Remove some product, we'll push the equilibrium towards the right. Another reason that this is more favored than just the aldol addition is because we have this conjugated pi system, which helps make the product more stable and thus more favored, right? So think about the steps that would go on here. First, it would be the addition, which is generally going to be not favored for ketones. Right, this beta hydroxy ketone. And then upon the application of some heat, we'll get the condensation step. And this will be favored due to the conjugated pi system and the fact that we're removing some water.